Hello, Assalamualaikum. My name is Hariz Azfar bin MOHD, and today I will present about my final year project. And the topic of this project is Design and Fabricate Portable Waste Engine Oil Filtration Unit for Automotive Services Center. And my Dr. Muhammad Iman Hakimi Chua bin Abdullah has guided me on completing this project. So this is the presentation content of this project. Introduction. So, as a background, waste engine oil is a high polluting substance. Used lubricant engine oils are byproduct of oil used in vehicles and machinery. Most engine oil contains a lot of different chemicals with very different properties. So, the aim of this project is that most of the technology to filtrate the waste engine oil comes at a high cost. As a result, the aim of this study is to discover a low-cost method of producing used engine oil. The procedure is less costly than conventional methods due to moderate conditions of the process. Next, the problem statement. For the problem statement on this project, engine oil must be changed from an automobile after a few thousands of kilometers or when it is no longer serve a purpose that is fully reliable. Changing the engine oil will produce a waste engine oil, which is a high pollutant material that requires a proper management. Waste engine oil may cause damage to the environment when dumped into the ground or into water streams, including sewers, and that's why we need to filter the waste engine oil. Objective of this project is to design and stimulate a portable oil filter by using SolidWorks. Second, to fabricate the portable oil filter with suitable filtrating material. And lastly, it is to test the developed oil filter compared to lead scale. And the scope of this project is to designing and testing the performance of the portable oil filter with SolidWorks and analyzing the design, product, and the spec of structure using the tools in SolidWorks. Fabricating the portable oil filter with analyzed suitable oil filtration membrane and lightweight, oil-corrosive, durable material. And lastly, it is testing and the fabricated oil filtered compared to lab scale filter unit. So, next chapter is the methodology. So I use SolidWorks 2021. This is because it is capable of making an accurate drawing with the 3D display, and it also provides features such as the material use and analysis that can be beneficial for the testing desired function of the product before fabrication. And lastly, result drawing can be used in 3D printing, which is in this case a SLS printing sheet. So this is the blueprint of the design, which conclude the final product of the design, the top view, bottom view, and the side view. Also, there is an isometric view of the design. This is the detailed design. The design consists of 8 parts, which include the base, body 1, body 2, filter, filter funnel, head, reservoir, tank, and sponge filter holder. As for the material selection, in this project, the SolidWorks 2021 software provides features for the designer to assign the type of material for the design and its properties. Testing and analysis of the assigned material for each part of the drawing will be conducted. This is to ensure the effectiveness of the design before fabricating. Next, in material testing, I use 1060 alloy for tank reservoir. This is just for the testing on one part, and the tank reservoir shows a deformation. The material selected for the part is not suitable as it could not withstand the force that will be applied to the part surface. Next is technology used for fabricating. First, we use laser cutting, a technology that uses a laser to cut material. Next, lathe machine, a type of machining tool that is used to shape hard materials. Lastly, 3D printing, which is in this case, we use SLS printing technology that converts powder form material into a desired 3-dimensional shape after being heated. So, for laser cutting, it is a high-powered laser beam distributed by the laser cutting equipment to either cleanly cut or etch a specific design of material such as steel, plastic, or wood. The raw material will be cut by using the laser cutting machine equipped in the manufacturer laboratory. Lathe. The workpiece is rotated around a stationary cutting tool. It is really useful in the process of fabricating a cylinder-shaped material. and it is used to fabricate the body of filtration unit. Lastly, 3D printing machine. The fusion process begins at the top of the design, continues through a cross-sectional view from the top perspective, allowing the powder to harden layer by layer. This technology has a low cost per part. Next part is the analysis of the product. We use the SolidWorks static analysis, SolidWorks displacement analysis, safety factor, and computational fluid dynamic, features of computational fluid dynamic. This is the SolidWorks static analysis. The simulation provides many load conditions to a plant surface. Stress, strain, and deformation of a component or assembly can be analyzed under a range of load conditions to ensure that costly failures are avoided during the design stage. These analyses are evaluated to examine the effect of working environment and operating conditions of the design based on the material chosen. SolidWorks displacement analysis. The displacement analysis will produce stresses and displacement as the output when force or loads is applied to the product design, perform deformation animation of the product design. Lastly, safety factor. Safety factor, the ratio between the strength of the material and the maximum stress in part, described as the structural capacity of a system's ability to withstand loads that are higher than planned or actual. Safety factor must actually at least 2.0. The higher the safety factor, the more reliable the design. For the next part, it is the results and discussion. So this is the part for the product fabricated product. This is the inner part of the product where it undergoes filtration. This is the first filter, and the second filter. The first filter, the oil will go through the side of the filter, and this is the body of the fabricated product. This is the base, and this is to collect the filtered oil, and this is the oil that I took from this engine oil, waste engine oil I obtained from this motor, and we're going to test this product. Now I already installed this full, the engine part and the outer part. Now we're going to test. We're going to pour 500 ml of oil. After done pouring it, then we just need to open this. So as you can see, the oil is coming out through the pipe where we collect the oil after. As you can see, the filtration test, we use the 500 millimeter of oil sample, waste oil sample, and we conduct between these two, product filtration and lab scale filtration. So the product filtration, you can see that it is rely on gravitational force only, and for the lab scale, it has the support of vacuum pump. And product filtration only took 23 minutes to complete the filtration process, while the lab scale filtration took 200 minutes. So the comparison analysis of this testing, lab scale filtration unit shows a higher time taken to complete the filtration process instead of product filtration. You can see the graph of lab scale versus product filtration. It is much faster for product filtration to complete the process. So why there are differences in this result? There are factors. One of it is technology applied for the system, and second is filtering material surface size. And next, after we validate the final product, we conduct a market survey. It is to collect data and allow research and analysis of the market. And next is to understand their characteristics, expectations, and requirements. Lastly, it is to ensure that this project is applicable and brings benefits to the community. This is the analysis on the market. As we can see, the characteristic is most important for the filtration unit. It is the reliability, where people depends on their reliability, and The expected for the filtration unit to function, it is 3 to 5 years as usual. Uh, Many people would like to have a long, long life of the product, and the reasonable cost for this product, it is 100 to 300, as our aim is to build a low cost product, and this is and this is one of the target that we need to achieve. And lastly, many people would like to have a portable instead of immovable product, and our product met this criteria. So conclusion and recommendations. As conclusion, a new portable oil filter is developed using SolidWorks software. Application of durable materials by referring to the SolidWorks material library. Portable waste engine oil filtration unit is fabricated referring to the design, and the durability and endurance of the product is discovered. Lastly, filtration process has been tested for both product and lab scale. The objective of this project was achieved. So, as a future recommendation to improve this portable waste oil filter, some additive must be added to the product, such as acetic acid, which has been discovered to be useful in recycling waste engine oil. Use an external technology to impart extra pressure through the oil, where this product only consists of rely on gravitational force. So use the external technology that has low cost. The surface of the filtration material should be wider, as a factor of the faster filtration process, because the surface area of the filtration material, and design a broader channel to pour the waste engine oil. This is to avoid the oil spill from pouring the waste engine oil into the product. And lastly, produce a holder in the design concept. The holder is very important as it is portable, and you need to make it as user friendly as it can. So that's all for my presentation. Thank you.